Hi, this is Richard C. I'm a math tutor with Wyzant, answering a question from a student, submitted by a student. This is a nice little question. It's a very typical question that you'll see in Algebra 1 or Algebra 2, depending on what level you are at. You might see it in level Algebra 1 honors class or something like that. Okay, so I'm going to start by drawing a diagram here to match this. So let's just draw a rectangular shape. Oops, sorry about that. It has a length and a width. It's supposed to look like a rectangle. Let me get it to look like a rectangle. Okay. And we're told that we have 300 feet of rope to enclose this space. So we know that 2 lengths plus 2 widths is 300 feet. And if we divide everything by 2, we know that the length plus the width is 150 feet. Now we're interested in the area. The area is equal to the length times the width. And the length you can see here, I think you can see that if I just rewrite this equation, the length is 150 minus width. And so I can rewrite area as 150 minus W times W. And you might recognize that this is a quadratic equation. And this is in its factored form. If I wanted to distribute the equation, I'd write negative W squared plus 150W. And now it's a parabola in standard form. And I think it's clear that you can see that we've now expressed area as a function of width. Let's go ahead and graph this parabola. We know the parabola goes through the origin because why? Because when the width is 0, the area has to be 0. So here's area here. And width here. And we know it goes through this. Now the other 0, and you can see this from the factored form, when W is 0, area is 0, or you can look here and you can see that when W is 0, area is 0. But we can also see that the parabola goes through the point 150, comma 0, 150, because when W is 150, 150 minus W is 0, and anything times 0 is 0. Now we can sketch the curve. And it's a parabola opening down. And if you remember from your standard form, whenever the leading coefficient is negative, you have a parabola opening down. So all of this reinforces everything you've learned about parabolas. It's just being put into the context of a word problem, and that's what makes it a bit of a challenge. Now, the maximum area obviously is occurring at the vertex. And you should have learned with parabolas that parabolas have this wonderful symmetry here, and the vertex is just the midpoint here, which is going to be 75. Now, we don't know the height here yet, and that's what they're asking us about. But we do know that the width is going to be 75. And from this equation here, we know that the length is going to be 150 minus 75, which is 75. So we actually have a shape that's a square. The length and the width are the same. The area is just going to be 75 times 75, which is going to be, on my calculator, it gives me 5625 Now, the answer is not asking us for units, but this would be, the answer is, giving us units. So this would be square feet, because this is 65 feet. And this is 75 feet, and this is 75 feet. So it's feet squared is the units of the area. And so this is our answer right here. So what makes this problem hard? Well, I think it's just takes a little getting used to, where you're taking two variables that are given to you in a pretty obvious way, which is this step here. But then they're asking about area, and area involves two variables as well. And now you really have a system. It's kind of like having a system of equations. We don't have a value for area. So if we had a value for area, I think you would see this as a system of equations. You'd have L plus W equals 150, and then you have L times W is equal to area. But we don't know what the area is, and that's what makes it a little bit tricky. But we can solve the problem by just behaving as if it were a system of equations and express area in terms of width alone. Okay, so that's it for today. I hope you continue to enjoy your word problems in algebra. Everybody hates word problems, but try your best. Okay, bye-bye. See you next time.